Imagine standing in an empty desert at night, with nothing around you but flat ground stretching all the way to the horizon. Now imagine that somewhere far away, a giant light switch and an equally giant speaker are placed side by side. At exactly the same moment, both are turned on. The light switch flashes once. The speaker emits a sharp, loud bang. You are about to watch a race that almost never feels like a race in real life. The flash reaches you instantly, or at least it feels instant. Your brain doesn't register any delay at all. Light moves so fast that on human scales, distance almost doesn't matter. The sound, however, takes its time. A few seconds later, the bang finally arrives, rolling across the desert like a slow-moving wave. This difference is so familiar that we barely think about it. We see fireworks before we hear them. We see lightning before thunder follows. But the gap between light and sound is far larger than our intuition suggests. To make this difference visible, let's slow the world down in our imagination. Picture a tiny stick figure standing 1 meter away from the light in the speaker. At that distance, sound takes about 3/1000ths of a second to arrive. Light takes about 3/100000ths of a second. Even slowed down in your head, the light still wins by such an absurd margin that it's basically unfair. The stick figure would see the flash long before any part of the sound wave has even decided to start moving. Now let's move the stick figure farther away, 100 meters. The sound now takes about 1/3 of a second to arrive. You could blink in that time. The light still arrives so quickly that the delay is completely invisible. If you tried to animate this honestly, the light wouldn't look like it's moving at all. It would just appear everywhere at once, like reality suddenly updating. So let's zoom out, way out. Imagine the stick figure standing 1 kilometer away. The sound takes about 3 seconds. You could count them out loud. 1, 2, 3. Only then does the bang reach your ears. Light, meanwhile, arrives in about 3 microseconds. That's so fast that even high-speed cameras struggle to make it feel like motion. If sound is a jogger, light is a teleport. At this point, sound starts to feel embarrassingly slow. You could almost picture it as a visible ripple crawling through the air, pushing molecules aside one by one. Each molecule bumps into the next, passing the message along like a massive, invisible crowd doing the world's slowest relay race. Light doesn't bother with that. It doesn't need air. It doesn't wait for permission. It simply goes. Let's make things even more ridiculous. Suppose the stick figure is on one side of a large city, and the flash and bang happen on the other side, 10 kilometers away. Sound takes about 30 seconds to arrive. You could check your phone. You could get bored. You might even forget what you're waiting for. Light, meanwhile, arrives in about 33 microseconds. By the time your brain registers the idea of flash, it's already over. Now imagine trying to visualize both at once. Picture a glowing sphere expanding outward at the speed of light. Next to it, a much smaller, slower bubble represents sound. At first, they start together. Almost immediately, the light sphere becomes so large that it swallows the entire scene. The sound bubble is left behind, still hugging the source, inching outward like it's stuck in slow motion. If we keep scaling up, the comparison becomes almost comical. From the Earth to the Moon, light takes about 1 1/3 seconds. Sound can't even make the trip at all. There's no air in space to carry it. The sound bubble simply dies at the edge of the atmosphere, while the light keeps going, completely unbothered, racing across empty space. Now let's bring time back into the picture. Imagine a stick figure watching the sun suddenly flash brighter for just a moment. About 8 minutes later, the light reaches Earth. That sounds slow until you remember that the sun is 150 million kilometers away. Sound wouldn't just arrive late, it would never arrive. Not in minutes, not in years, not ever. Here's another way to see how extreme this difference is. Imagine you could ride on the sound wave, surfing through the air at the speed of sound. From your perspective, everything ahead of you would be perfectly quiet. You would be carrying the noise with you, like a moving bubble of chaos. Now imagine trying the same thing with light. There is no riding alongside it, no catching up, no standing still relative to it. Light doesn't allow that kind of relationship. It always moves away from you at the same speed, no matter how fast you chase it. By the time sound has crossed a football field, light has already circled the Earth more than 7 times. By the time sound has crossed a city, light has reached the moon and is on its way back. By the time sound has crossed a continent, light has left the Earth entirely, heading out into the galaxy, carrying silent images of everything we've ever done. So when we say that light is fast and sound is slow, we're not just describing a small difference. We're talking about 2 completely different categories of speed. Sound is fast for a human. Light is fast for the universe. And if we could actually see both of them moving at their true speeds, sound would look like it's barely trying, while light would look less like motion and more like a rule of reality snapping into place.